Hello everybody, welcome to today's video. This is part 5 of the Solving Linear Equations series, and today we're going to be solving absolute value equations. So let's get started. Let's go over the basic properties of how to solve these type of equations. The first is that if you take the absolute value of an expression, that should be greater than or equal to the value of 0. So I'm going to show it by this number line that if you take the absolute value of a number like -5, you will get the answer 5, which is greater than or equal to 0. All right. So let's go to the second property. If you take the absolute value of a negative number or a negative expression, that's the same as taking the absolute value of the positive expression. And if you multiply within an absolute value, it's also the same as saying the absolute value of A times the absolute value of B, and the same applies for division. For division, the only thing is that B cannot be equal to 0, because if you take a number and divide it by 0, you will have an undefined answer. All right, let's get into example 1. So example 1 says x minus 4 is equal to 6, the absolute value of x minus 4. So you want to solve this in 2 steps. You're trying to create 2 equations here, and I'll explain why in a minute. So our first equation is going to be x minus 4 is equal to 6. So what I did was I just removed the absolute value signs. And now what my goal is that I'm trying to isolate x. So I'm just solving for the variable. I'm just trying to make x independent. All right, so by adding 4, I get rid of the -4 on the left side of the equation. So we have x is equal to 6 plus 4, which is 10. And -4 plus 4 is just 0. So we can just say x is equal to 10. Then we do it the second way. Second way is saying x minus 4 is equal to -6. So the reason why we have 2 equations is because when we take the absolute value and we're trying to find the value of x, there are 2 values that can work for x. You can have a positive value work for x, and you can have a potentially negative value work for x. But there are 2 values that will work, and I'll go ahead and show you guys that in a minute. So we're going to say that the first one is equal to +6, the second one is going to be equal to -6, and now I'm just solving for the value of x. So I get that x is equal to -2. So what we want to do now is check. What do I mean by check? I'm saying take those 2 x values, plug them back into the equation, and are they valid? That's exactly the question we're asking. So x minus 4, absolute value of that is equal to 6. So 10 minus 4 is equal to 6. Absolute value of 6 is equal to 6. 6 is equal to 6. So x equals 10 proves to be valid. Now let's get the x is equal to -2. Let's see if that's valid. So we say -2 minus 4 is equal to 6. And -2 minus 4 is equal to absolute value of -6 is equal to 6. And the absolute value of -6 is 6. So 6 is equal to 6. And that means that x is equal to -2 is valid too. Right? So what we have now is that we're not just trying to solve the value for x with one solution. We actually have 2 options, 2 answers, right? So our 2 values of x that satisfy this equation is 10 and -2. All right, let's do the same process for example 2. So we're first going to write the original equation. We're just going to take away the absolute value sign. So we're going to have 3x plus 1 is equal to -5. So that's our first way that we're going to do it. And then our second way, we'll get to it, but we're just going to make that -5 into a +5. All right, let's isolate x. So we're going to subtract 1 from both sides. And we have 3x is equal to -5 minus 1, which is -6. And we divide both sides by 3 to get x is equal to -2. We'll plug that back into the original equation just to make sure that this is a valid answer. All right, now let's do 3x plus 1 is equal to 5. So all I did was make the -5 into a +5. Now let's subtract 1 with both of these, both sides of the equal sign. So we can isolate x. So we have 3x is equal to 4, which means that x is equal to 4 over 3. Now, here is why I say we have the importance of checking, because as you will see, when I replug this into the equation, those answers that we got are not valid. So let's do x is equal to -2. So we'll say 3 times -2 plus 1 is equal to -5. So the absolute value of -6 plus 1 is equal to -5, which means the absolute value of -5 is equal to -5, but the absolute value of -5 is 5. So this is not valid. So x is equal to -2, we can rule that out. Maybe x is equal to 4 over 3, maybe that's a valid one. So let's go ahead and check that. So I'm going to plug that into our original equation. So we're going to get the absolute value of 3 times 4 over 3 plus 1 is equal to -5, which means that 4 plus 1, absolute value of that is equal to -5. But absolute value of 5 is equal to -5. Well, that's not true. 5 is not equal to -5. So both of these are not valid. That means if you have two solutions that we got that are not valid, there is no solution. This is unsolvable, right? So we cannot get, and no value of x will satisfy this equation. And as you'll notice, our basic property was that if you take the absolute value of an expression, that should be greater than or equal to 0, and this gives us an answer of -5, which is a negative number. So just by noticing that basic property, you'll be able to, you don't have to solve the whole thing. All right, so now we have example 3. So in this example, we have 3x plus 9 minus 10 is equal to -4. This is a little bit more complex because we have that -10. So what do we do with it? We have to get rid of it. We only want the left side to contain the absolute value. So I'm in a way, I'm making the absolute value independent, and then I'll make the variable independent. So let's add 10 to both sides. So we have absolute value of 3x plus 9 is equal to 6. And -10 plus 10 is just equal to 0. All right, so then we just bring the 3x plus 9 down. And this is the equation we're really trying to work with. So we're going to just keep it the same. 3x plus 9 is equal to 6. And then we'll do a -6 one. So we're going to subtract 9 from both sides. So we have 3x is equal to -3. And if I want to isolate the value of x, then I can divide both sides by 3 to get that x is equal to -1. Now let's do the same thing, but we're going to do it for our second equation. So I'm going to go ahead and rewrite the problem. So the problem was 3x plus 9 minus 10 is equal to -4. So let's rewrite it, and the first two steps are going to be exactly the same. So here we're just trying to make the absolute value independent. So how can we do that? We can add 10 to both sides. So we get rid of the -10 on the left side of the equal sign. So we will get 3x plus 9 is equal to 6. So exactly what we got before. But now our 6 is going to actually be -6. So we're going to isolate the x. So we're going to subtract 9 from both sides to get rid of the positive 9. We have -15 on the right and 3x on the left. Divide both sides by 3. So we get x is equal to -5. So you'll see that when we have x is equal to -5, we have to plug in x is equal to -1 and x is equal to -5 into the original equation to check if these answers that we got are valid. And that's a very important part of solving absolute value equations, is that you want to make sure you're not getting the wrong answer. All right, so let's check it for -1. So we have 3 times -1 plus 9, that is an absolute value, minus 10 is equal to -4. So our question that we're asking is it actually equal to -4? So the absolute value inside of that will have -3 plus 9, and then we're going to have -10 outside of the absolute value, minus 10, and that's going to be equal to -4. Now inside the absolute value, we have 6. The absolute value of 6 is just 6, but 6 is equal to -4, well 6 minus 10. And then we'll see that x is equal to -1 is a valid answer because -4 is equal to -4. Now let's go ahead and check -5, So let's plug it back in. So we can say 3 times -5 plus 9 minus 10. And that should be equal to -4. So 3 times -5 is -15 plus 9. Minus 10 is equal to -4, and -15 plus 9 is equal to -6. Absolute value of -6 is 6. So we're going to subtract 10 is equal to -4. So we'll just solve this simple algebra, and we'll get -4 is equal to -4. And since we got that, we know that this is a valid answer. So for this one, we have x is equal to -1 and x is equal to -5. These are our two solutions, two values of x, which make the equation correct. All right, let's go to example 4. Similar to the last one, except we have that -2 we have to deal with. So the first thing I'm going to do is I'm just going to make the absolute value independent, right? So how do I do that? I add 3 to both sides so I can get rid of that -3. So -11 plus 3 is -8. I bring the -2 times 5x minus 1 down. Divide both sides by -2 because I want to get rid of that -2, and -2 divided by -2 is 1. So we have 5x minus 1 in absolute values is equal to 4. Now this is the equation we're really trying to work with, which is much simpler than what we originally got. So we're going to take 5x minus 1 is equal to 4, and then our other equation is going to be 5x minus 1 is equal to -4. So let's make x independent. So we're going to add 1 to both sides. We have 5x is equal to 5. Divide both sides by 5 so that we get x is equal to 1. If this algebra doesn't make sense, please watch my other past videos because it's important to develop a base knowledge before going on to things like this. All right, so we have x is equal to 1. That's one solution or possible solution. We haven't checked it yet. Our second solution is 5x minus 1 is equal to -4. This is our second equation. So we're going to add 1 to both sides, and then we're going to go ahead and divide both sides by 5. So we have -3 on the right, 5x on the left, divide both sides by 5 so that we get x is equal to -3/5. So now we have two potential solutions. So now we're going to go ahead and check this. So I decided to check on a separate piece of paper. I recommend you do the same when you're doing your checks. You can do them on scratch paper. All right, so we have, we're going to plug in x is equal to 1 into the original equation. So we end up with an equation that looks like this. And we're just trying to prove that the left side is equal to -11. So we're going to say -2 times 5 minus 1 minus 3 is equal to -11. Inside the absolute values, we get 4. It's not -2 times absolute value of 4. We have to first find the absolute value of 4, which is 4. So that's like a small little step, but we must include it when we show our work. So -2 times 4 is -8 minus 3 is equal to -11, and -8 minus 3 is equal to -11, which means that x equals to 1 is a valid solution. It's confirmed. All right, let's do the same thing, except now we're going to be plugging in our second solution that we got. All right, so now we have this equation. We're trying to prove that the left side is equal to -11. So here, 5 times the -3/5 is just equal to -3. So inside the absolute value signs, we have -3 minus 1. Now we have -2 times -4. Minus 3 is equal to -11. -4 absolute values resolves to 4. So this is our new equation, and -2 times 4 is -8 minus 3, which means that -11 is equal to -11, making the second one also a valid solution. So now we have our two answers confirmed, and that's when we decide to box it in. All right. So let's go ahead and do example 5. Example 5, how is this different than the other examples? We have absolute values on both sides of the equal sign. So is there a different process? Are there different steps? No, they're the same process. So let's do 3x minus 4 is equal to x. That'll be our first equation. And our second equation will just be 3x minus 4 is equal to negative x. All right, so first let's combine the like terms. So we'll subtract 3x from both sides. So we have negative 2x on the right and negative 4 on the left. So now we will divide both sides by negative 2, and then we'll obtain x is equal to 2. And negative 2 divided by negative 2 is 1. And that's the reason I'm dividing both sides by negative 2. So this is our first potential answer. Then we have the second equation, which is 3x minus 4 is equal to negative x. So we will subtract both sides by 3x because we're combining like terms. That'll give us negative 4 on the left and negative 4x on the right. Divide both sides by negative 4 to isolate x. And then we get x is equal to 1. These are two potential answers, and now we have to go ahead and check it. So these are, once we do that, we have to plug it into our original equation. So we have to say 3 times 2 is equal, minus 4 is equal to the absolute value of 2. Is that true? So we get the absolute value of 6 minus 4, which is equal to 2, and the absolute value of 2 is equal to 2, so this is a proved answer. Then we prove the second one. We say 3 times 1 minus 4 is equal to the absolute value of 1. So the absolute value of 3 minus 4, so we're saying the absolute value of negative 1 on the left side. Absolute value of negative 1 is 1, so 1 is equal to 1, which means that this is a valid answer. So these are our two solutions for this equation. So hopefully that made sense. Let's go to example 6. This is a little bit more complicated, so please try this on your own. So let's go ahead and try to solve this. So we're going to do it the same way. 4x minus 10 is equal to 2 times 3x plus 1. First, we just solve the equation as it is, right? So we don't really change any signs or anything. So we're going to say 4x minus 10 is equal to 2 times 3x and 2 times 1. Here's where I'm doing the distributive property bubbles. So we're just multiplying the bubbles together. So we're going to say 2 times 3x plus 2 times 1. All right, so we have 4x minus 10 is equal to 6x plus 2. So we're just simplifying it down. Now we're solving for x so we're going to add the like terms, add or subtract. In this case, we're subtracting. So I'm going to subtract 4x from both sides. So I get rid of it on the left side. I'm left with negative 10 is equal to 2x plus 2. Now let's combine the like terms of 2 and negative 10. So we end up getting negative 12 is equal to 2x. And then we divide both sides by 2. So we get x is equal to negative 6. So that is our first potential answer. So x is equal to negative 6. So what we first are doing is we're isolating, we're just trying to isolate the value of x, and we do that by combining like terms. All right, so let's do our second way. So our second equation that we're going to create, it is 4x minus 10 is equal to negative 2 times, or a negative times the right side of the equal sign. So let's just copy it down. And the main change that we're going to make is to that number 2, right? And this gets a little bit messy, mainly because we're doing the distributive property on the right side. So we have 4x minus 10 is equal to negative 2 times 3x plus 1. That's the key. Right, you got one equation with the right side positive, the second equation with the right side negative. And that's basically, if you understand that process, then all the questions are pretty much the same. So 4x minus 10, and we're going to distribute the negative 2 into those two other bubbles I created. So we have negative 2 times 3x plus negative 2 times 1. And we associate the sign with a number. And we'll worry about signs later. right? So I know we have a plus and a minus, but we'll resolve it later. So negative 2 times 3x is negative 6x, and negative 2 times 1 is negative 2, but the negative will overpower the positive, so it becomes 6x minus 2, negative 6x minus 2. Now we combine like terms, so we're going to subtract 4x from both sides. This will get rid of the 4x on the left, so we'll end up having negative 10 is equal to negative 10x minus 2. Now we're going to combine the negative 2 and the negative 10, so we're going to add 2 to both sides. So we get negative 8 on the left, and that's equal to negative 10x. Then we divide both sides by negative 10, so we get x is equal to a positive number, because a negative divided by a negative is positive. So we end up getting 4 over 5. And these are potential answers. We got to check them, okay? So let's go ahead and check. So we're going to plug this back into our original equation. So 4 times negative 6 minus 10, is that equal to 2 times 3x plus 1? So that's what we're trying to resolve. So we see that 4 times negative 6 is equal to a negative number, because a positive times a negative, is equal to negative 24 minus 10. And that's equal to 2 times negative 6 times 3, which is negative 18 plus 1. Then we're just doing some simple algebra, solving it down. So we end up with 2 times negative 18 plus 1, which is negative 17, which means that the absolute value of negative 34 is 34, and 2 times the absolute value of negative 17. That will also be equal to 34. So since we have 34 is equal to 34, we know that x is equal to negative 6 is a valid answer. Now let's do the same thing, except we will be plugging 4 over 5 into the equation. So here we have, on the left side, we're going to say 4 times 4 over 5. And on the right side, we are doing 3 times 4 over 5. So here it's a little bit complicated, maybe just mainly because of the fraction portion. But 4 times 4 over 5 is equal to 16 over 5 minus 10. That's equal to 2 times 3 times 4 over 5, which is 12 over 5 plus 1. Now 16 over 5 minus 10. So we can say that 10 is equals to 50 over 5. And when we resolve that, we get negative 34 over 5. And on the right side, we get 2 times 17 over 5. So we end up with 34 over 5 because the absolute value of a negative number is a positive number, and 2 times 17 over 5, which is also 34 over 5, which means that our answers, both of them, are valid answers. Perfect. So that concludes today's videos. Those are the 6 examples. Please tune in for the next and final part and subscribe to our channel. Thank you.